If you don't manage memory placement and thread affinity, you could be paying double or triple the latency for every single access. When your program allocates memory, the operating system decides which NUMA node's memory to use. And when a thread accesses that memory, it either hits local memory, which is great, or it ends up reaching across other memory, which is bad and slow. Think of it like this. Imagine a multi-socket motherboard. Socket 0 has its own RAM bank, and also socket 1 has its own RAM bank too. If a core on socket 0 accesses its own RAM, that access will be fast. We call it local memory. But in the case that this core tries to access a RAM on socket 1, it has to go through a special interconnect, which is basically a remote memory, and it is much slower. Accessing memory locally may cost around 80 to 100 nanoseconds, but in the case of remote access, you may face 200 to 300 nanoseconds. Multiply that by millions of access in a loop, and your application runs even slower than your local machine. And this is the worst part, because you cannot debug this on your local laptop because you don't face it there. But every time you upload your program into the server, which has 2 or 4 sockets, for example, you will face every time that your program slows down, and things can get ugly very fast. This is why many high performance apps like databases, video encoders, machine learning algorithms, they are all NUMA aware, and yours should be too.